remember how to find the area trapped between two curves? We did that yesterday. So I'm going to just draw some old function. And here's f of x. And let's go from A to B. And if I want to find this area that's trapped in here, remember that we drew a rectangle, right? What's the base of my rectangle? Okay, guys in the back? This is new. This is a BC topic. That's delta x. No. I want the area just of one triangle. Triangle, rectangle. So that is all together. Okay, so the area for one rectangle, it's base times height. The base is delta x. What's the height? It's the y value. So the area from A to B is going to be my y value times dx. Okay? If you understand this, then the rest is going to follow really quite nicely. And there are 3 problems. So yes, I'm going to collect this assignment tomorrow. Should be able to get it done in class today. Okay, so here are my parametric curves. X is equal to f of t, and y is equal to g of t, and we are given the time. Remember that? This has to do with vectors, too. And, well, we'll see. It'll come into play. I want the area. I'm going to actually find out what this area is if I do the integral from y, if I do y dx. I'm just actually going to substitute it right in there. So what's my y? Y is what? G of t. So I'll rewrite it. The integral. I'm not going to put the a and b there because that's for x, but it was y dx. So it's the integral of y. Well, y is g of t. And what's dx? Dx is equal to f prime of t times what? Don't forget the differential, dt. So this is f prime of t dt. And what do you think you're going to integrate from? The times or the x's? Times. From alpha to beta. So if you can remember that, I don't know if that was going to show up. That doesn't really show up too well. If you can remember, let's try friend. If the integral of an area under a curve is y dx, then if you're given parametrics, all you do is put in the y value, find dx, which is the derivative, times dt. And that's all there is. Mostly it's going to be a calculator problem. So let's do a problem. There it is. I'm going to have a little problem with this because I need to know where these things, I need to know the time. Should we look at the graph first before we try to do this? I think that'd probably be smart. So we're going to have to change to parametric mode. I don't have any calculators. All my calculators have disappeared. So I can't loan you a calculator. I can loan you my iPad with the calculator, but then you have to know what you're doing. And I don't know how to do parametrics on here, but somebody might. And so we're going to change this to parametric mode. So we go to mode, and we're going to switch it down to parametric. Next week, you'll learn how to do the polar mode on your calculator. And I've seen these problems on the exam. Okay, so I'm going to clear out what I have because I have no idea what's there. Okay, so x of t is t squared plus t plus 1. And y of t is 3t to the 4th minus 8t cubed. Nicer if you have pretty print. Minus 18t squared plus 25. problem for me is getting the window. Did the x's ever become negative? Did I put it in right? Put that away, please. The x's never become negative. If you look at the discriminant of this, you get the square root of a negative number. There are no zeros in that function. And if I really want to see what the values are going to be, I'm going to do, pardon? No, even if you put in a negative 1, the t has to be between 0 and negative 1. And even if you do that, this is still going to, because of the 1, it's always going to be positive. So you can argue with number theory, which is very nice. Okay, so pay attention. I don't know what to set my window at. So you know what I'm going to do? I'm going to go second table set. Honestly, I don't know what to set my window. I know my x's are going to be pretty easy. Let's start at 0. We might want to do negative time, but we'll see. And then go second table. So as I look at that, my x's are going to get big pretty fast, aren't they? What if I go back up? Negatives. I probably want some negative signs. But look what happens with my y values. They're huge. So, you know, I got to get the right values. But if I go, t is negative 2 to 3, maybe I want to go down to negative 50 or something. 65, negative 65, well, we'll just try it. You know, I don't know. So let's make this negative 3. And x, t max, we made it 2. T step looks okay. X min is 0, I know that. What was the biggest x? I forgot already. I suppose I could take a picture of this. There. But the problem is then I have to do this. I should get this fixed. Okay, so now I've got something in front of me. So if t is equal to 3, x is going to go up to 13. So we're going to go window, and let's go up to 15. That may still be not very good, but we'll see. Oops. I had it right. And the y mins, let's go negative 65 to 65. And we may zoom in on it when we figure out what's happening. They don't expect you to know what's happening. Are you ready? I'm going to change my y scale to 0 because I don't want to see the tick marks. And I'm going to change my x scale to 0. Did you know that? They just don't get any tick marks then. Okay. Because then it won't put any tick marks on the axis. Because if I have an x isn't too bad, but the y's would have a lot of them, and then you get a thick-looking axis. If anybody wants to try my Inspire, I have not done parametrics. Which one? The t? I went negative 3 to 2. Maybe I should go negative. No. Reason why I stopped at 2 was that was okay on the y's. It was negative 63, but then it jumps to negative 110. I think we've seen this one before. Are we ready for me to press graph? Oh, okay. Now that's not a bad picture, except guess what? I want to see this little region right there. Oh no, I wasn't going to zoom in. I'm going to change my window. Now, of course, silly me, I took the tick marks off. You know, would you like to do a box zoom on that? You guys know how to do it? Somebody said zoom in, and I said no, but let's do that. Let's zoom, and let's do a box. And then I have to move my cursor. Don't press enter until your cursor is where you want it. No. So you just make a box around it. So you basically turn opposite corners. Oh, that's much better. That looks like a fish. Okay, so there we are zoomed in. But you know what? I have to know where it intersects. So you're going to do the best you can. I do a trace, t is negative 3, I go to the right. I'm waiting to find the cursor. There is no other way to find the intersection point. Okay, it's pretty close. The first t is negative 1.35. Pretty close. What's true? What's true about x and y? I can't think of it. What's true about x and y there? At that point. They're going to intersect here, right? Oh, I should have taken a picture of that. I need the numbers. Can we do it algebraically? Probably not. You know, someday that's probably going to happen. If they can control the technology. You might be the person that figures out how to control the technology so that people are locked out and you can, whatever's in your calculator, your phone, or your iPad, whatever it is. So I want to integrate from there to where? Now I got a little problem because what direction is this going? Is this going forward or backwards, really? Started here. It's going backwards. We'll find out because we're going to actually integrate this on our calculator. Okay, that looks about as good as we can get. And those are your t values. Okay, so let's do this. Here's one t value, and here's the other one. Notice the signs there. Okay, remember what it is. It's the integral of y dx. What's y? What's the y value? 3t to the fourth, I can't see it, minus 8t cubed, minus 18t squared, plus 25 times dx. Now what's dx? 2t plus 1 dt. And we're going to integrate on the t's from where to where? Negative 1.35 to 0.35. So that's what we're going to do. We're going to do it on our home screen, though. Yeah. Yes, they'll either give them to you or it'll be easy for you to find. You actually could solve to find them.
How can you not find them? If they're not a way to find the intersection point.
I could find the intersection. You can't do it graphically on your graphic calculator. Not with the t's. If you go back to the other mode, what's true about x and y there? They intersect. So x and y are equal. I don't know how to solve that algebraically, but I can solve it graphically. I could find these two intersection points there. If you have a CAD calculator, it's really easy. It still only has one. But it has twice. It happens twice. Because we saw it. Well, let's integrate this. We can check with the book, too, because I thought it was a little closer than that last year, but I don't remember. And we're going to quit. I'm going to slide this over. There. Second quit, and we're going to type that in. Oh, that's okay. That's not bad. Okay, so it's math 9. And I want that in there? Ugh. Okay, I'm going to do this. And y equals? I'm going to change my mode. I just didn't want to type it in. I'm sorry. Well, you don't have to. You can do it in parametric mode, but then you have to type it in. Because you don't have that in there. That's okay. So in y1, I'm going to put in 3x to the fourth. Yes. Did you get it exactly? Minus 8t cubed. That's the caret. And every single calculator, they move everything around. Drives me nuts. plus 25. The reason why I didn't want to type it into the home screen is I'm not going to do it very well. I'm going to make a mistake with my parentheses. And this is 2t plus 1. I don't remember the answer. It's the example problem in your book. Whoops. I don't need that. Okay. Second quit. So it's going to be y1 times y2. Anybody have the new operating system? Then you go alpha, calculate, and you can pull y2 quickly. But you can only do it on 84. Comma, x was my variable, comma, negative 1.35. I don't think they give us anything as tricky as this one, 2.35. And there it is. Guess I don't have to worry about the fact that I went backwards. Nope. No, I did y2 multiplied by y1. y1 times y2. It's right here. 3.628. I think I'm going to check it with the book, because you know. What? Y2, I put the 2t plus 1. Yeah, see, that's the reason why you don't want to do it in parametric mode. You'd have to change that, because it's y times dx, not x. It's not the y value times the x value. It's the y times the derivative of the x. Well, we're going to look it up, because I want to make sure that I did that right. I'm pretty sure I did. I thought they did this one. Maybe we did it out of the old book. Thank you.
Actually gonna put those in.
I believe that's the right answer. Yeah. Well, just have to do it. Oh, who can grab me one of those black books up there? Or does this have a number with it? No, that's it. Thank you. Yeah. Because I didn't just make this up. Okay, let me check my answer. Yes, they have 3.6. We did it right. Thank you. They wrote it as two integrals, but you see that you can just write it as one. You guys know why that works? Do you guys know why that works? When you integrate from here to here, that does all of that. And then when you integrate from this point here to this point back over here, it does all of that, and it subtracts them, and you're left with just this in-between piece. That's why it works. Okay, you have just a few problems to do. You had 2 from yesterday. You have 3 more. I don't know if that's the right numbers. Is that what's on the assignment sheet? Go by the assignment sheet. Yes, I will be collecting 6-1 tomorrow. 34, 35, 37. So this is what you should be doing. 2, 4, 2, 4, which isn't much. 34, 35, 37. This is to get the kinks out of your brain. Collected